Welcome back. So in this video, it's going to be a first example of writing a polynomial function given is 0. So the n here, the first characteristic is n equal 4, and n stand here for the degree. So the highest exponent on the variable x is 4. So it's a 4th degree polynomial, even degree, okay, polynomial. And then the zeros occur x equal 3 and x equal -3. And it has a complex number, which is 1 plus 2i, or complex root, because you can see the I, the imaginary unit I. Okay, so now how do we write? So step 1, you're going to use our knowledge of the fundamental theorem of algebra, which states that if we know the degree, okay, we know the number of solutions. So we have, the degree here is 4, so you must have 4 solutions, right? But when you look closely, the solution listed here are not 4. If you count them, you have 1, 2, 3. You don't have 4 solutions. You only have 3 solutions, 3 roots. What does it mean? Okay, is the fundamental theorem a lie? No, it's not a lie. So if the degree is 4, you must have also 4 solutions. So remember I told you in class that when you have complex roots, the complex root always come in pair. What I call complex root number with the imaginary unit I, where A you can see the bi is not 0, the b is not 0. You can see actually the imaginary unit I. So complex root always come in set of 2, in pairs, in pair. So if you have x equal 1 plus 2i, the other one will be what? Is complex conjugate. So they're going to share the same real part, which is 1, and opposite imaginary part, which is -2i. So I need you to remember this, okay? That complex conjugate, complex root, will always come in pairs, right? So that's why the solution will be here then. We have 4 solutions. 1, 2, 3, 9, 4. So this is the 4th one that they did not include. They didn't write it out, but they assume that you know that, okay, complex roots always come in pairs. Then you're going to move backward. You want to derive the factor. And again, to derive the factor, the first step that you need to do here, you want to get to the part where you take each factor instead of equal to 0 by applying the 0 product property. So you're going to minus 3 here, so that the right side can be equal to 0. So you get x minus 3. And then the other one, it's x equal minus 3, so you're going to add 3 on both sides. And you're going to end up with x plus 3 equal to 0. The next one is, again, is 1 plus 2i. You want to get 0 here, so you're going to minus 1 and minus 2i. And whatever you do on one side, make sure you have to do it on the other side. Minus 1 and minus 2i. So the equation is going to be x minus 1 minus 2i equals 0. And the 4th equation is, again, is going to be 2i and minus 1. Okay, so I should have done x minus 1 plus 2i equals 0. Okay. So whatever you do on one side, on the right, you have to do on the other to balance the equation. So now we derive the factor form, which are x minus 3. The first one is x minus 3, x plus 3, x minus 1 minus 2i, and the last one is x minus 1 plus 2i. You don't need equal to 0 because you want a polynomial function. So we don't want an equation. So now we derive the factor form. What is the next step? You're going to multiply. And I will say step 2 asks you to multiply the term with the I first. So I'm going to multiply x minus 1 minus 2i times x minus 1 plus 2i. And to multiply those, you can use a box method or distributive property, but I'm going to use here the distributive property. Okay. So because the first factor is made of 1, 2, 3, so I have to do 3 rows. So you have x minus 1 minus 2i. And the second factor is made of 3 terms. So I have to do also the same thing. I have to make 3 columns. So you're going to be x minus 1, 2i. Okay, so you're going to multiply across. So let's multiply. X times x is x squared. X minus negative 1 is negative 1x. Okay, and x times 2i is going to be 2ix. And then negative 1 times x is negative 1x. Negative 1 times negative 1 is positive 1. Negative 1 times positive 2i is negative 2i. Negative 2i times x is going to be negative 2ix. Negative 2i times negative 1 is positive 2i. And negative 2i times positive 2i is negative 4i squared. Don't forget the squared on the I, on the imaginary unit. Okay, let me move it up. Okay, so let's continue multiplying. Okay, we are done multiplying. Did I do it correctly? Let me check my work. Always double check your work. Okay, everything is fine. Let's continue. So now you're going to combine like terms. So I have x squared. I cannot be combined, so I leave it alone. So negative 1x plus negative 1x add up to negative 2x, right? So those two, I combine it to negative 2x. Now, those two here cancel out to 0. Why? They are opposite of each other, so they cancel out to 0. 2i and positive 2i plus negative 2i add up to 0. Okay, then you end up with plus 1, okay, and then minus 4i squared. Now, remember in algebra, for imaginary units, I squared means you can replace I squared with what number? Yes, negative 1. Okay. So you end up with x squared minus 2x plus 1 plus 4. So you end up with x squared minus 2x plus 5. Okay, so we factor, so basically you factor the factor with the imaginary unit I, okay, right here. And the product is x squared minus 2x. Okay, now what do we do next? So next you're going to multiply. So you're going to multiply the factor x minus 3 times x plus 3. Okay, the first factor in front. So let's do that. You're going to multiply. So the answer is going to be the factor. Okay, the first factor is made of 2 terms. So, and the second factor is made also the 2 terms. So I'm going to have 2 rows and 2 columns. So x times x is x squared. X times 3 is 3x. Negative 3 times x is negative 3x. Negative 3 times positive 3 is negative 9. Okay. Is there any term I can combine? Yes. They're opposites. They cancel out to 0 actually. Positive 3x plus negative 3 add up to 0. And then you're left with x squared minus 9. Okay, so what would you do next? So remember, we have, what happened is we multiply the 2 factor with the imaginary I, the complex root factor, okay, and you end up with x squared minus 2x plus 5, okay. Now, we factor also the real factors, like x minus 3 times x plus 3, and you end up with what factor? With x squared minus 9. So what I'm going to do next is you're going to multiply those two together again. Okay, so let's do that. Okay, so let's continue. Okay, so I multiply those 2 factors. So the first, on the side here, I would x squared minus 9 for the first factor on the left, and the second factor I would it above, x squared minus 2x plus 5, and I multiply. Okay, so and then okay, so now do you see any terms that we can combine or I cancel out to 0? So what I notice, x to the 4th power is by itself, so there's nothing to combine x to the 4th power with. Then we have x cubed. Do I see any x cubed anywhere else? No. So it should be negative 2x cubed Now, I can combine those two together. Negative 9x squared and positive 5x squared add up to negative 4x squared. Then I have the plus 18x minus 45. So since they ask for polynomial functions, I'm just going to label it or name it y. You could use f of x, but I'm just going to choose to name it y. And that's the end. Okay, so again, this is n. Remember earlier they said the polynomial is n degree. It's a 4th degree polynomial. And what we have here, again, we have a 4th degree polynomial. So this 4th degree polynomial we have for zeros 3, negative 3, and complex conjugate pair of 1 plus 2i and 1 minus 2i. So thank you for watching my video. Have a wonderful day and see you into the next one. Bye-bye.